So this is 24 paper, right? Uh, the code is 4CH1, 4SD paper 1C, right? The box gives the names of some substances, bromine, chlorine, diamide, ethene, iodine, lithium, methane. Okay, a good conductor of electricity among the given elements. Okay. All right. So a good conductor of electricity is yeah, it's going to be lithium, right? Diamond is a non-conductor, right? It's an insulator. Okay. So it should be a lithium. An element that is liquid at room temperature, it should be bromine. A substance that can be used to form a polymer. Yes, a substance that is used to form a polymer.
So can you show the options again?
Yeah, yeah. Yeah. So a substance that can be used to form a polymer. So it should be ethene, right? Ethene. Because a polyethylene substance is formed using ethene, right? An element that forms a basic oxide. Yes. An element that forms a basic oxides. Alkali
Uh,
elements or alkali metals form basic oxides. So it should be lithium, right?
I think chlorine.
Chlorine is a non-metal. Okay, it forms acidic oxide, not basic one. A substance that has a giant covalent structure. A substance that has a giant covalent structure. Yes,
Diamond.
yeah, it should be diamond, right? All right, so describe a test for chlorine. How can we test chlorine? Yes, since chlorine is acidic or basic?
Acidic.
Okay, so it turns the blue litmus paper to red, right? Uh, use a dam, okay, dam blue litmus paper. If in the solution of chlorine either or or uh, placed at the mouth of test tube where chlorine is formed. Okay, it turns blue litmus paper to red. Okay, right? We can also use a universal indicator, right? We can also use a universal indicator paper. Okay, and then we can observe the change of color. Okay, and one thing that the litmus paper also turns to white. What is the action of this? What is the action? This is the bleaching action of chlorine. Okay, right? The paper uh, turns to white, showing which thing? showing bleaching action. Okay, bleaching action of chlorine, right? This question is about the reactivities of metals. The table shows the reaction of four metals PQR and S with water and with dilute hydrochloric acid. PQRS, okay, reaction with water, very fast reaction, and no reaction and slow reaction. Okay, reaction with dilute, no reaction. Okay, dilute hydrochloric acid. Right. So deduce the order of reactivity of the metals. So which one is going to be most reactive? The one which is least reactive cannot react with water and cannot react with hydrochloric acid. So which do you think can be the least reactive metal from the reactivity series? Yes. So the most reactive, the least reactive is going to be the P1, right? The least reactive is going to be P1. Okay. And the most reactive is going to be very fast. Okay. Very fast with water, right? Very fast with water. Therefore, it should be Q. Okay. And what about the other ones? R and S. So no reaction with water and slow reaction with water and fast reaction with hydrochloric acid. So it has to be S and R, right? S is more reactive than the R, okay?
Sir, how is S more reactive than R? R should be more reactive than S.
Why it is not showing any reaction with water? R is not
Sir,
showing any with water.
sir, but if we compare the hydrochloric acid वाले result को अगर
Mhm.
compare करें, so we see
Yes,
that S is more reacting faster than the R.
but look at the reaction over here. It is saying no reaction,
Oh,
right?
okay.
It's not saying that it is fast or slow. Yeah. So on the basis of this one, on the basis of this no reaction, it has to be kept under less reactive. Okay. All right. So give the letter of the metal that could be zinc. Which one could be considered as zinc? Yes, type. Would you like to give answer? Which
Yes.
uh no S zinc reacts with hydrochloric acid, right? They are saying not done. Sorry, no, no. S. Oh, okay. So zinc can react with water, but not slowly, right? It has a moderate reaction with water. Okay. So zinc doesn't show reaction with water. Okay. Right. It doesn't show reaction with water. Therefore, it has to be it has to be R, right? And it reacts slowly with the HCl. Okay. Right. Uh, Give a word equation for the reaction between aluminium and hydrochloric acid. Yes, word equation should be aluminium plus hydrochloric acid forms uh, aluminium chloride plus hydrogen gas, right? Okay. Give the name of a metal that could be P, which can be considered as P, since P is not showing any reaction with water and not showing any reaction with hydrochloric acid. So they are going to be the least one, right? the least reactive, it could be copper, silver, or gold. Okay, right? Copper, silver, or you can say gold. Give a reason why the reaction of Q with dilute hydrochloric acid is not done. Give a reason why Q with dilute hydrochloric acid is not done. Q, where is Q? Okay, so it is reacting very fast with water, right? But it is not done with hydrochloric acid. What do you think? What could be the reason that it's not done? Do you think that it is vigorous? Do you think it is
Yes,
explosive,
बहुत
right?
ज्यादा तेज रिएक्शन हो जाता है.
Yeah. So it has to be give a reaction why the reaction of Q with dilute hydrochloric acid is not done because uh Q uh can be can be rigorous, we can say, or we can also write vigorous or explosive, right? Explosive with uh HCl, right? Okay. Um, I think it should be violent, right? It should be violent, not vigorous. It should be violent because we are actually talking about the you know the danger of that reaction. Okay. All right, so here we go with another part. The diagram shows the apparatus used to demonstrate the reaction between aluminum and iron 3 oxide. Um, Magnesium fuse is there. When the magnesium fuse is light, a very exothermic reaction occurs, right? This is the equation for the reaction iron oxide plus uh, aluminium is reacting and forms aluminium oxide, right? State what is meant by the term exothermic. So we already discussed the concept of exothermic, where the heat is given out or released, right? Okay. So exothermic reaction in which heat is released out or evolved to the surrounding, right? Right. Okay, so the next question says that state why aluminum displaces iron. So this concept is also very easy because aluminum is more reactive, or it is it is placed higher or in the uh, in the reactivity series of metals, right? Okay. So aluminum is more reactive than iron, right? We have to write in the very specific way. Aluminium is uh, reactive than iron. Okay. Explain why this reaction is a redox reaction. Uh, if you recall, in redox reaction, uh, you know, one element loses the electron and another element gains the electron, right? So we have to we have to come up with the concept that which one is being oxidized and which one is getting reduced. Okay. Okay. Right. So there must be the change of oxidation numbers, right? And which element is losing the electrons and which element is gaining the electron, we have to specify. Okay. So in a very simple way, if you look at the reaction, so over here, aluminum does not have oxygen, right, in the reactant side. But after the reaction, aluminum has gained oxygen, right, and forms aluminum oxide. So, aluminium is gaining oxygen, right, from from where? From iron oxide and forms aluminium oxide. Okay, right. This is one of the way to define the redox, right? One is losing and one is gaining. Okay, right? So uh, oxidation is actually addition of oxygen, right? Okay, so the one which gains the electron is being oxidized, right? And since iron is losing oxygen, so it is getting um, reduced. Okay, so we have to write in this way. Uh, uh, Aluminum is gaining oxygen from iron oxide and forms aluminum oxide and getting getting oxidized where iron from iron oxide loses oxygen, thus thus iron is getting reduced. Okay, right? The next question is about uh, okay, if I want to explain in terms of the uh, gain of electron, right? So here, aluminum has zero charge because when the element is alone, right? So in a free state, so it has zero charge on it, right? So after the reaction, iron has a zero charge, right? Now, if you look at iron over here in the iron oxide, so you can see here that the charge of iron is +3 and oxygen is -2, right? And over here, the charge of aluminium is going to be +3 and oxygen is going to be -2, right? Now, if you look at iron, it is going from +3 to 0, right? So there's a decrease of oxidation state, right? There's a decrease of oxidation state, right? Okay. And here you can see that aluminium from 0 to +3, there's an increase of oxidation state. Okay, increase of oxidation state. So the decrease of oxidation state is That means this element is getting reduced, okay? And increase of oxidation state means that element is getting oxidized, right? So I hope that you got this concept, right? Okay. Uh, in question number 3, the diagram represents an atom of element Z. Z is not the symbol of the element, okay? So give the number of the group to which this element Z belongs to, right? So what is the group number? Hello, if I am audible, hello.
Yeah, yeah.
Okay. So give the number of group, yeah, or group number. So how many electrons are there in the valence shell? Yeah, in the last shell there are 2, right? So ultimately, what do you think? This element that is Z, right? It belongs to group 2, okay? So give the number of the group. So it's going to be uh like this. Either you can write in this form way, or you can write in this way, okay? Give the number of the period to which element Z belongs to. Yeah. So how do we find the number of period? By looking at the number of shells, right? So 1, 2, and 3. So how many shells this element has occupied? It has occupied 3 shells. Therefore, the period number is 3. Okay, right? Clear? Give the formula of the compound that forms when Z reacts with fluorine. Okay. So since it belongs to group 2, and all group 2 elements are the electropositive elements, right? And they exhibit a positive 2 charge, okay? Since they belong to group 2 elements, so they exhibit positive 2 charge. Therefore, when they react with fluorine, okay, so when they react with fluorine, so, oh, it's not zinc, sorry. It's not zinc. So when it reacts with fluorine, okay, so it will form ZF2. Why? Because the fluorine belongs to group 7. The charge on fluorine is going to be -1, right? And the charge on Z is going to be +2, right? So by writing in the crisscross manner, by we can conclude the formula here. ZF2. Okay, Y2 is here because of having the charge +2 on Z. Okay. One mole of C contains 6.0 into 10 to the power 23 atoms, right? Calculate the number of electrons in 1 mole of atoms of element Z. Give your answer in standard form. Yes, number of electrons. We have to find out number of electrons. Yeah. Since 1 mole of atoms, so if you look at the number of electrons in the structure, so 2, and then 8, and then 2. Wait, excuse me. So it's going to be 12, right? So there are going to be 12, uh, and each atom consists of 12 electrons. And how many atoms do we have? We have 6.0 into 10 to the power 23. So we will multiply the 1 atom electrons with 6 times 10 to the power 23 atoms, right? So we got this, right? Now, if you can tell me the answer, 6 times 12 is going to be around 72,
Yeah,
right?
7.2 times 10 power 24.
Yeah, 7.2 times 10 to the power 20, right? Electrons.
24 times
Okay.
10 to the power 24.
Oh, 24. Thank you. All right. So a sample of element Z contains three isotopes. The table shows the number of particles in the nucleus of each isotope and percentage abundance of each isotope, right? So if you look at the percentage abundance of one isotope and the second isotope and the third isotope, so you see 79.0, 10.0, and 11.0, right? So we have to use this information, right? We have to use this information to find out the uh, uh, use the information in the table to calculate the relative atomic mass of element, right? Okay. So yeah. Uh since uh in the nucleus, there are the protons and the neutrons, right? The nucleus, there are the number of protons and the neutrons, right? So uh over here, if you look at the number of protons and the neutrons, right? So here we go with 24, right? So 12 plus 12, it will make 24. And in the isotope 2, we have 12 plus 13 is going to be 25, right? And 12 plus 14 is going to be 26, right? Okay. Now, see the abundance, right? Look at the percentages of each isotope, right? So we have to, uh, we have to take the mass number. This is the mass number, right? Because mass number is the sum of protons and the neutrons, right? This is also mass number. This is isotope 1, okay? This is isotope 2. This is isotope 3, okay? This is also the mass number of isotope of 2 and then mass number of isotope of 3, right? So how are we going to find out? We'll multiply. Yeah. So we'll take the mass number, right? We'll multiply the mass number with the percentage abundance, and then we will divide by 100, right? Okay. So we have 24 times the abundance is 79. So we'll multiply with 79.0. And then we add 25 times 10 is the abundance. And then third is 26 times 11.0, right? So we divide by 100. Okay. So what are we getting? Yes.
24.3.
24, right? 24.3. So it's going to be magnesium, right? Yeah.
Yeah,
Yeah.
yeah.
Uh, So inshallah, we'll be doing this question in the next class, right?